Thanks, Wendy, and it's a pleasure to be here to take part in this colloquium. Apologies for arriving late and not being able to stay until tomorrow, but I already see the connections in Wendy's imagined program already. The fact that electromyogram may have been used there, and the haptics, those are two things that I'll talk about from a musical perspective. So yeah, music, human-computer interaction, from digital musical instruments to design with visually impaired users. Slight change from the published title, but you'll see what I mean. But I want to first start with the proposition that music is supersonic. Okay? Because, of course, music is cool. I'm very happy to be a musician, and it's a very fantastic line of work to be in. People like music. But that's not what I mean by supersonic. By supersonic, I mean that music goes beyond sound. Music is more than sound. It's not just sound. Music is visual, music is tactile, and music is social. And so in that sense, music is not a thing, as in a work, it's an activity. And it's Christopher Small, in his seminal book, he's a music educator, he wrote the book called Musicking, where he turns music, a thing, into musicking, a verb, from a noun to a verb, from a thing to an activity. And he undoes the hierarchies of music to say that all engagements with music are equal. Okay? So for me, music is also visceral. It engages the body. It creates corporal experiences, and in that sense, it's phenomenological. Okay? So that's Kathy Sapovi, who's performing a piano piece of mine in Brooklyn a couple of years ago before the pandemic, and what we see is that she's in movement, she's in motion, and she's grasping her arms. They're not even on the piano, right? But that's part of the music, that is the performance. And we'll see an extract from that same piece by another pianist later. So I want to think, in the context of this colloquium, of what I can bring as a composer, as a musician, to this question of human-computer partnerships. And so this talk is really in three parts. One where I introduce the notion of music HCI, okay, the research methods and interaction paradigms that we draw upon. Then I'll present this idea of the body as musical instrument, using the body, in particular the electromyogram, in forms of research that we call artistic research, or in French, recherche création. Okay. And then the third part of the talk will be to present a device called the Haptic Wave, transferring some of this music research approaches to creating accessibility tools, and to do that in a cycle of user-centered design. So first, music research and HCI. It's really interesting. Got two cursors here. And if I had goggles on, what would I actually see and what would be the relation? Okay, there we go, they disappear. Okay, so music-human-computer interaction is the intersection of research in computer music with research in human-computer interaction. Okay? And in that sense, it's a conversation. It's a conversation to say, what can we in music research, how can we benefit from knowledge in HCI? Approaches of working with users, evaluation methods, and this broad notion of human factors. But conversely, what can we as musicians bring to HCI? This idea of musicians as virtuosi, can we bring that as a kind of expert user to music? And in fact, Wendy has very much articulated this idea and carried out major projects with the idea of extreme users. But can we also think about sound itself as an interaction medium in a society that is so visually centric? Okay. And can we think about music as a cultural activity, as a form of situated activity in what we call third wave HCI? And we'll get to that in a second. So this broad field is really coalescing at the moment. There's a key book in the field edited by Simon Holland and Tom Mudd, and they have just created a research network in the UK called Chime, C-H-I and Music Network, in which I'm a participant. But whereas the Chime Network has just happened this year, and that book was published just a couple of years ago, this conversation between music research and HCI goes back about 20 years. And it's in the field of new interfaces for musical expression, NIME, where we see that relationship, because NIME started as a workshop at CHI 2001. So it is a field that came out of a bunch of people doing music at CHI. From there, it's become its own standalone conference. Okay? So quite often, there is a kind of confusion to say, oh, well, is NIME music HCI? Okay? And in fact, in the end, NIME may or may not be music HCI. Indeed, we do benefit from HCI methods. Okay? But in fact, that's a constant debate. This question of evaluation is a constant debate in NIME. Some people are up for it, wanting NIME to go rigorous, to become scientific. Others are saying, oh, hold on, we're making music. We can't just tick checkboxes and do evaluations. Not to say that that's what evaluation is. No. But really, NIME is different in that sense because it is making music systems for musicians and musicers. So if we take the idea of musicking, to those who do the musicking, those would be the musicers, wouldn't they? And so it's the E in NIME, okay, the interfaces. In fact, there was a long time debate in what the acronym should stand for. Should it be new instruments for musical expression or new interfaces for musical expression? So by interfaces, we give a little ground to HCI, and with the E word, expression, we're exploring the expressive dimension that we can really dig into with methods of artistic research. So now the little lesson in third wave HCI, very risky to do this in a specialized audience such as this. If I get it wrong, I can be corrected. But broadly, the way the story goes, that over the decades of human-computer interaction research, the first wave of HCI research was what was called human factors. Okay? It was more engineering focused, following a cognitive science paradigm, formal methods, okay? And systematic testing in terms of task performance. Okay? That broadly we can say was the work in the 80s. In the 90s, as computers found themselves more broadly in use in office and work situations, those settings then became the site of HCI research. And we might say that we moved from a cog-sci paradigm to a social science paradigm, okay? Looking at group work and collaborative work, and this idea of communities of practice that one get cited. And so we moved from this human factors era to a human actors era. And then, since the 2000s, we've entered what we call third wave HCI, moving then from workplace setting to everyday settings, moving from a social science paradigm, perhaps, to a cultural studies paradigm, studying experience and meaning making. And it's here that Wendy has coined ideas like technology probes, where we might create new kind of rocket science and interaction propositions, but then set them as probes in daily lives, in people's homes, to study family situations. Okay. So I've written a little bit about this to think about whether music follows this and whether music may be situated in that third wave of HCI. So the question is all music interaction third wave HCI? Indeed, music is cultural. Yes, third wave. It's intuitive, but at the same time, for those of us who play music, we know that music is extremely technical. It takes a lot of work to learn harmony, to learn notes, to perfect the actual performance of an instrument, the knowledge of music theory. And so I would claim that that can be evaluated in first wave techniques. Okay? So that's the dyad, isn't it? Music is play and music is work. Well, as long as it's play, we can say that it's third wave. But if it's work, and we know what work it is as musicians, that's second wave. Okay? And obviously, if it's social and personal, it's third wave. So we get third wave a lot, but there is first wave and second wave in there. The other word that I'd like to unwrap is the word performance. And this is a word that has different meanings depending on the context that we're in. So if I'm on stage, I'm used to that. As a musician, we perform. That's an expressive artistic act. But the same word is used in engineering, okay, to say how fast does your car go, how many clock cycles can your computer do. So that's the first wave view of the word performance. And in fact, even though we may say, oh, that's the artistic, that's the cultural, that's third wave, no, we know that being on stage, we have to keep our mind on many things. So there's actual work going on stage when we perform music. And we might actually think about that from a second wave perspective. So then where's the third wave gone? Well, it may be in the third use of the word performance that I draw from the sociology of Irving Goffman, a major text for us in HCI research, interaction ritual essays on face-to-face behavior, written almost 50 years ago now, where he looks at human-human interactions in everyday life. Okay. From a performance point of view, he unwraps daily interactions by using metaphors of theater. Okay. So we might say that then that's the third wave use of the word performance. So I find it interesting when one word can have those three different meanings and three different, perhaps, types of HCI approaches kind of all wrapped up into it, because music, especially computer music, englobes all three of these meanings of performance. So with that as a sort of HCI introduction, I'll go into then the body as musical instrument. So this is the question of embodied interaction with music. We're associating gesture with computer-based sound. Increasingly, we're using technologies of machine learning, but I'm interested in what the human is learning as the machine learns. I won't have time to get into detail of that. But the most recent work, we're now then starting to associate brain signals and body signals. So as the history goes, this stuff is quite old. In terms of the body as musical instrument, we can go back up 100 years to instruments like the theremin that took antennas that would allow us to detect then the presence of the performer's hands near the antennas to control pitch and amplitude, much like playing a violin, but by free space gesture in thin air with an electronic instrument. Okay. It's Alvin Lucier that nearly 50 years ago pioneered the idea of brainwave music. So he's sitting on stage in a piece called Music for Solo Performer. It's hard to see, but he's got a headband on. There's an instrumentation amplifier sitting on the plinth to his right, detecting electroencephalogram signals that are then amplified and used to activate actuators on percussion instruments. Okay. Musicians like Letitia Tsunami, working at studios like Stime in Amsterdam, started to create new musical instruments using wearable sensors already in the 90s. The lady's glove is a series of bend sensors, accelerometers, etc., that then allow her to create a new digital musical instrument. So my place in this tradition is to use the body directly. And so therefore using the electromyogram signal, muscle tension, in music. So is this a new musical instrument? Or can we use this to extend existing instruments, like put an electromyogram sensor on a pianist? Or could there be non-musical applications? And we have, I've got a PhD student at the University of Valladolid in Spain, Jose Manuel Corredera, who is a medical doctor interested in using EMG and sonification to do rehabilitation. So what is the interest of muscle sensing for music? It's something we call biosignal computing. We can look at the signal energy of gesture, of muscle tension. Okay? And with Baptiste Carmiot, who's in the room, we saw that, in fact, the user subjective sensation of effort does correspond to the signal energy. It's maybe intuitive, but it had to be shown. And then from an experience point of view, in the sensing, whether it's motion capture, the inertial measurement units coupled with EMG in the handover case, or in cases where in animation and other forms of interaction, including our daily interaction with mobile phones, we've got sensors everywhere. But sensors observe the movements of our body after they're done, or as they're being done at best. A computer vision system like the Microsoft Kinect watches the body. This sensor looks at the Cartesian displacement, okay, after that movement is done. But if we're detecting electromyogram, we're looking at the intention of making movement. Okay? And in fact, it may be a signal that arises before the movement happens. And this is the intention of the body to do something. And we found that, in fact, there's almost a kind of inverse latency where the muscle tenses before the resulting gesture takes place. So in an engineering situation where we're trying to minimize delay, minimize latency in a lot of these sensing systems, here, by looking directly at the body, we've inverted it right away without having to find any technological solution. We're just tapping the gesture at the right point at the source. So this research has been going on for the better part of a decade. I held an ERC project where Baptiste did his postdoc. We had artists like Marco Donnarumma looking at muscle interaction, and sound artists like Alessandro Altavilla starting to bring listening into user-centered design. That led to a follow-up proof of concept project by a musical instrument where we worked with hardware engineer Martin Klang to create our own hardware for electromyogram detection that is a musical device. That device is MIDI and audio. Okay? And we started to roll in the interactive machine learning tools that computer scientists like Rebecca Febrink created into music programming environments that we use, called Max. So all this takes place, as I said, as artistic research in performance. I perform experimental music solo and in different groups and bands. I've written a piece for piano and EMG, which has now been picked up by 4 pianists around the world, originally commissioned by Sarah Nichols in the UK. Performed that's Dawn Williams in Malta, Kathy Spovi, you saw the picture in the earlier slide, and Giussi Caruso, I just met in Antwerp last week, is learning the piece. As a composer, I'm transmitting the piece as a score, as the EMG sensors, and as the interactive software. But using this model of a composer transmitting a work, then that is, can be learned and played and transmitted across different artists and across time. We've also had, in the pop music world, an all-female band, Chicks on Speed, who performed with our experimental EMG board in Switzerland a couple of years ago in a major museum exhibition of sort of a retrospective of Carolee Schneemann. They performed a work called Noise Body by James Tenney, the composer, and Schneemann, the artist at Museum Sush. So just as an example, I'll play a little bit from Sarah Nichols' performance of Suspensions in hopes that the audio will work. Oop. So all sounds are from the piano itself, but granulated in this case of the electronic sound. But she's able to play piano sound without being on the piano. Can we have a bit more volume? time we'll stop it there. But that's the dream of the pianist, isn't it? Piano is a melodious instrument. It's an instrument where phrasing is everything. But mechanically, piano is a percussion instrument. You press a key and it makes a sound. But all the music is in the phrasing in between. We have the sustain pedal, the soft pedal. And so with the EMG, we're able to take the pianistic gesture to extend the sound of the piano beyond the touch on the instrument. So we wanted to then take this idea of working with electromyogram and put it in a user context, in a cycle of user-centered design, where users then become part of a design process, where we create scenarios and situate context, and where running workshops becomes a method. So if music becomes musicking, workshop as a thing become workshopping as an activity. So this is where our research and qualitative research, drawing upon ethnomethodologies, takes place and enables us not just participation in research, but forms of bottom-up thinking that allow the emergence of ideas and perhaps surprises and the unexpected. So the next video I'll show you is actually me trying the electromyogram on a hip-hop musician from a band called Blue Lab Beats. And so this is his first time. He just walked into my office, we stuck it on, we threw some of his samples in the system, and this is literally his first encounter with the system. Oh, let's see. I'm in trouble here with it's a little smile. It's been a minute. We can set the threshold, the trigger threshold, higher or lower if you like. And there's a sort of a re-trigger threshold as well. So you need to go below a certain point to try and explain the system triggering. Okay. Yeah, so we'll go now, just the tilt is the sample. So he has to turn the filter off. And he keeps playing with it. It's getting more rhythmical. It's getting into the groove. Tapping his foot now. Okay. There's a piano part that comes in afterwards, but he was quite happy. But that was a nice moment. Okay, and the most recent work now in this sort of series of funded research is that we've had good fortune to be funded by the Agence Nationale de Recherche in a project that's just started this year, running 3.5 years, called Brain Body Digital Musical Instrument, or BBDMI, where we put the electromyogram in context with brainwaves, electroencephalogram, in a user-centered design cycle. So this then brings the humanities-focused artistic research in music together with neuroscience in a user-centered design context. And I'm happy to have my colleagues here, Anne Sedes from the Maison de Sciences de l'Homme Paris Nord, our neuroscientist Stephen Whitmarsh from the Institut du Cerveau. We also have the Center for the Création Musicale at Université de Paris 8, and a company called 60 Circuits doing design. So that's where we're headed. Now we see Stephen on stage in brain music performance. We've had the early pioneers of brain music come to present at events and festivals that Stephen has organized. We're going to use the EMG board that was created in my proof of concept project, And we are interested to work, amongst others, instrumentalists and musicians who suffer from autism. And so I've got an early sort of test of that at the Sonic Protest Festival last year, where we performed by putting electromyogram on a noise musician called Sika Noise. And we have students from the conservatory, some of whom suffer from autism, that will be part of the user group that we'll be working with over the next couple of years. So that's the body as musical instrument. I'm going to switch over now to the haptics. As a passive haptic device. There's a whole thing about actually the EMG, we do free space gesture, and passive haptics is in fact very useful, and that's something that remains to be explored. And the sound. Okay. Right, so Haptic Wave, cross-modal interface for visually impaired musicians and audio producers. Here we go. So the first question is, how can we take everything that I presented in digital musical instrument design and bring that to HCI research? Can we transfer the concepts and technologies from DMIs to working with users of diverse abilities? That is to say, can we take technologies that we have in the studio of motorized faders, the experience we have in working with real-time systems, and as you saw, gestural interaction, okay, to then transpose them to research to create accessibility tools, to pick up on ideas of cross-modal mapping of information, okay, all in a research through design cycle. So here is what editing audio was like back in the analog days. I don't know how many of you out there have as many gray hairs as I do, but when I was at Harvard learning electronic music, we started on analog tape recorders, and this is how we cut. And, cut and paste literally comes from this. Scrubbing tape. Five. So we find the spot where the word 5 is said, locate the tape head, and then we'll put the tape on the cutting block and cut the tape at that point. So it's very tactile. Now, with the advent of digital technologies, editing got super fast because it went visual. Okay? Graphical user interfaces allowed us to see the waveform of the sound, and very quickly, without having to temporally experience the sound, we could see right away where notes took place, where the music got loud or soft, where silences were, and start to then click the mouse and define edit points. But what if you're visually impaired? Okay. And you happen to be a professional in the recording industry? And there are a whole community of visually impaired musicians and audio producers. Okay? And they're working, so they're figuring out ways to work. Okay? And they have some accessibility tools at their disposal. This is the screen reader that comes built in with Mac OS, and essentially a screen reader, whether it's the one from Mac OS or whatever, the way that it works is that it reads out elements from the graphic user interface. It'll read you the names of the menus and the buttons. Okay? But how do you read an audio waveform? And if you're reading, it's a synthesized voice, then audio becomes a modality for the interface and the content that you're trying to work with. Now, rather than keep that theoretical, let's see what that actually means. If I can find my cursor. There we go. Videos are really odd. Oh, there we go.
Voiceover on peak, Le 7, Bark window, expanded disclosure triangle. Play plus pause.
There's our scrubbing bit.
You are currently on a disclosure triangle. To expand or collapse the contents of this item, press Ctrl, Option, Space, DSP menu, Audio menu 13 items, Action menu 24 items.
The screen reader's talking to us while we're trying to listen to the music.
Peak +7 has new window. You are currently on a disclosure triangle. To expand or collapse the contents of this item, press Control, Option, Space.
So you see the problem. And that's what we like in research, is a good problem, isn't it? So we have a simple proposition. If visual waveforms allowed us to see the sound, can we find another cross-modal mapping that allows us to feel the sound? So here are the users we worked with, 11 of them. I've got photos of 4. Joey Stuckey in Macon, Georgia. Sherry, who's an ebook editor in London. Scott, who, as you can see, is a heavy metal bass player. And Sheila Omodrian in Michigan, who is a very well-known computer music researcher. They were our users, and we were the researchers. And we thought of ourselves as actors in a research through design cycle, where we brought on board instrument builders from this community of new instrument design. And we embarked on a 4-stage process. It took a certain number of years. That's now quite classical and well-known in our field, running scoping workshops, building first a lo-fi prototype that led to a high-spec device, and then testing that device as a probe in real-world situations. So the scoping workshops, what we do there is to hear user stories, their experiences. Okay, we brainstorm ideas, and we might have some existing technologies that we want them to try out. So we're running workshops, and we pull quotes like this. You get so far, and then I come to a grinding halt. Remember, these are working musicians and audio producers who are visually impaired. So they work, and they tell us about their experiences. Okay?
What we want to be able to do is to scrub through a waveform.
Okay. And so some ideas come up in very sort of intuitive, natural ways. They don't know anything about the technology that we're about to propose.
What we want to be able to do.
Okay. So then, in terms of haptics, we have these devices like the Falcon there that allow us to get haptic feedback in a 3-dimensional space. And we had Scott try it out, and he said, what we did was to map the audio amplitude to the vibrotactile feedback. And he said, that's sort of interesting. I get it, but I don't know how useful it would be. Right? So you first get these negative results. You're like, because I can go up and down and left and right. What I would have expected is it actually mirrors the actual peaks and troughs of a waveform. So suddenly you're working with visually impaired users. We're trying to go into user-centered design. We're trying to be very respectful of their abilities, not using post-it notes, etc., not using visual metaphors. We were even hesitant to use the word see. And then he says, well, I want it to be like the peaks and troughs. So visual thinking is there, and it's not prohibited. But then he says, well, I want the force feedback, but in 2D rather than 3D. There are too many degrees of freedom. Okay? So we go to the drawing board to generate ideas for the lo-fi prototype. Lo-fi means whiteboard in this case. Well, it'll be more than that, but we started at the whiteboard to say that if we had a visual representation of the waveform, that's the blue squiggle, could we very simply use computer studio technologies, motorized faders, to sort of trace the amplitude waveform there? And how can we make that? So we made that by hacking an old scanner, tacking on some motorized faders, and putting some, I don't know if you know this material, sugru, to make the little knobs. Okay, connected to an Arduino, and then we tested it out. And right away he says, I don't want the top and the bottom. Okay, we thought the waveform goes above and below 0, so we would want to mirror the visual situation as much as possible. And right away he says no. And he says, I didn't even know that the inverse below the waveform existed. So as much as the first guy said, I want the peaks and troughs, then this guy says, well, I've never seen a waveform, so I didn't know. It can be rectified. I didn't know that the bottom half existed. And he says, by trying to twist my hand, it's an RSI nightmare waiting to happen. And then you're like, okay, we can't continue on like this. But then you get some nice moments.
Do it, the more it's making sense. There we go, see, silence. I need this.
And those are the little moments that you save.
Do it, the more.
So then we take our low-fi prototype. We know we want to get rid of one of the faders. Okay? And here's the sort of flipbook process in the design notebook, how we get from there to thinking about rails, working with better materials, faders and knobs, representations, then various designs. Okay? To then finally come to the haptic wave itself. And there's a lot of thought that went into that. It wasn't made out of wood just to look cool, but the industrial designer we worked with temperatures of material. Okay? To say that that yellow bit that scans across is plastic. It's actually ridged and is made of a kind of neutral temperature material, whereas the knob that goes up and down on the motorized fader is made out of copper. It's cold, and the wood around it is warm. So we're differentiating parts of the device through material temperature sensation. Oh, why do we have that again? Okay. So then we took that device, we made 3 of them, and we deployed them in the UK and the US and gave them to users to use in their own studios for any length of time from 2 weeks up to 2 months. They lived with it. It was integrated into their native working environments. We asked them to keep a diary, and then we did an interview coming up. So all the stuff I learned from Wendy in the idea of technology probes. So then we started to get interesting results. It's not a visual representation, but a linking representation. So it's an interesting concept. We hadn't even thought of that. It would give me the confidence to be able to know exactly where I am in the waveform. So this word confidence starts to become important if we think about some of the workshopping, the scoping workshop things. You know, I'm working and then I come to a grinding halt. They are working alongside sighted audio producers. They want to be as fast and as good. And so words like confidence are super important. It gives you this immediate intuitive indication. To me, it must be pretty much as good as a sighted person. So then he just says it right there. So we don't have to tiptoe around the tulips. And here we go. Here's our little video.
Get to zeros crossing, I think that's the quickest I've ever done it ever. You know, I mean, that was just like, I think I would get to the point where I would just have one, boom, bang.
We like that. But what we like even more is when the press pick it up. And so not to show off, but and knowing now that I have to click 3 times.
A new technology is helping the blind make music in Macon. Musician Joey Stuckey with Shadow Sound Studios says he discovered the haptic control surface technology while visiting Goldsmiths University in London.
That was my postdoc Adam Parkinson who worked on the project.
With music editing software, it shows Stuckey the dips and peaks in music he is putting together. As his hand glides across the board, a knob in the middle rises and falls with the music. Stuckey says he hopes this technology will be a great help for other blind musicians.
And I'm just so hopeful that we can move past the beta test stage into a stage where any blind person will be able to get one of these devices. I mean, that's the goal, and hopefully we'll get there. I'm hoping I can be part of making that journey possible, you know, that whole thing possible.
Goldsmiths University hopes the equipment can be released to the public in the near future.
Okay. So it's great to get Joey Stuckey to be an evangelist for us. But what was more insightful is that the newsreader could describe what the technology did. And that was really important, that she's the one who, in her own words, said it glides across and reads the dips and the waves in the waveform. So that was a little triumph for us.
A new technology.
Oh, no, we don't want to play it again. And so, just to wrap up, these were different ways that I hope we see how we might bring musical insights into the question of human-computer partnerships. We talked about music HCI, where music may be an interesting use case for HCI, perhaps sometimes an extreme use case. whereas we learn HCI methods in music research. That's brought about the NIME conference and today the CHIME Research Network. But I've been doing this using EMG as a musical interface for much longer than the conference and the network have existed, in sort of cycles of artistic research, making instruments, going on stage, working with musicians. So musicians then are users in this user-centered design cycle. But then transposing some of these ideas, some of these technologies, and some of these approaches to working with users of diverse abilities, in this case visually impaired musicians and audio producers. We then, if we come back to the 3 waves of HCI, I'd say we went into their studio, their working environment. So that was a second wave workplace setting. Okay? But we allowed them to then live with this technology probe. Okay? So perhaps we're drawing upon methods from third wave HCI, living with a prototype, keeping diaries, etc. Okay? But that when the musicians and the producers came back and said, I was able to do this faster, that's a first wave benefit. Okay? So tasks, speed, and accuracy were actual things that the users talked about. So in that sense, to come back to music is supersonic. Music is not just sound. Music is not just a cool cultural thing that you do. It is a lot of hard work, but some of that work that you put in, some of the expression that goes on stage can be captured, can be in some ways brought together with methods in HCI research to do some of the work that you've seen here. Thank you very much.